All right, here's 9-1, day 2. We're going to focus on the same concepts that we looked at in day 1, but we want to apply them to word problems. All right, just a vocabulary piece here to get started. Angles of elevation and depression, which are based off of what's called lines of sight. Lines of sight are always parallel to each other. If we have an angle of depression, we start with a line of sight that's at the top, and our angle of depression moves downwards. With an angle of elevation, we start with the line of sight that's at the bottom of our diagram, and that angle moves upward. All right, so if we just looked at this diagram right down here, this is an angle of elevation. This is an angle of depression. What actually comes up quite a bit, if I were to draw a perpendicular line right there, many times we get this confused that that's an angle of depression. Don't do that, okay? It's not. That's not an angle of depression. Angle of depression is always relative to this horizontal line of sight, and from there you move down. Angle of elevation, you move up. Here's a couple word problems. All right, I think we have 3 of them total to take a look at. If an 18-foot ladder is placed on a wall with an angle of elevation of 65 degrees, how far is the ladder from the base of the building? Well, here's the ladder. I'm just going to draw a really rough sketch. I think a diagram is a good thing to have. That angle is 65 degrees. This side of the triangle, which is represented by the ladder, is 18 feet. And what I'm looking for is this side length that's in blue. How far is that ladder from the bottom of the building? Okay. I'm hoping as you're setting this up that you see that we have a right triangle formed by the ladder, the wall, and the ground. And I want to use that triangle to set up a trig equation so that I can solve for x. Now after I have the diagram, the next element of this process is picking the right trig function. Okay, 65 degrees is going to be my reference angle. And the side that I'm trying to find is adjacent to the 65-degree angle. This 18-foot ladder is acting as the hypotenuse. And the trig function that I use has to include both of those sides. Now, it may not be a bad point here to pause to see if you could look up to see which trig function involves adjacent and hypotenuse. The answer is cosine. Involves adjacent and hypotenuse. So I could say as an equation that the cosine value of 65 degrees equals my unknown side over 18. It'll take one step here to solve for x, which again is the distance between the ladder and the base of the wall. X equals 18 times the cosine of 65 degrees. To get a decimal approximation, this is once again a point I would have to defer to my calculator to get it. The base of that ladder is 7.6 feet away from the wall. Example 2 says that if a person is 6 feet tall and casts a shadow 11 feet long, what is the angle of elevation? So here's my person. It's not a very good drawing, just a little stick figure. The person is 6 feet tall, and the shadow they cast is 11 feet. Remember, an angle of elevation always starts with the horizontal line of sight and then works its way up. Okay, so from the tip of the shadow to the top of their head, what angle is formed by this situation? Now the difference between this example and the one I just did is this one involves an unknown angle. All right, if you remember back to day one, this is a problem where we will have to use the inverse function. Now we still have to pick the correct trig function, though I think this situation is actually a little more clear as to which one to use. If I'm using theta as my reference angle, which I have to because it's the angle I'm trying to find. 6 feet is opposite, 11 feet is adjacent. Now those are the only two sides that I'm given, and I could certainly use the Pythagorean theorem to figure out the hypotenuse if I wanted to. But I don't. I don't want to. I certainly could, but I don't want to do more work than I have to answer this question. It's not that I'm not willing to, it's just I don't find it necessary. So I'd just like to use the trig function that involves opposite and adjacent, and that would be tangent. The tangent of theta is 6 over 11. Now in terms of solving for that, again, this is where I have to use my inverse operation. I need to take the inverse tangent of 6 over 11. I will need a calculator to help me do that, but whatever I get as a decimal approximation, that is approximately what angle theta is. Again, this approximation would come from the calculator. It's about 28.6 degrees. 28.6 degrees. Final example. Okay. An observer from point A, it's right here, is 250 meters from the base of a building. The angle of elevation to the top of that building is 5 degrees, which is marked in our diagram. Approximately how tall is the building? Okay. Now I'm gonna split this up as a couple of different problems here. If we were to just kind of follow the previous examples that we did to solve for A, I would hope that you would do this, that you would recognize that the unknown side is opposite of the 5 degree angle of elevation. The adjacent side that we know is 250 meters. We have that as well. And then I would take the tangent of 5 degrees, which is opposite over adjacent, and then multiply both sides by 250 to get side length A. Okay, that would be consistent with what we did. And you could certainly do that. You could get A, and that would be fine. Now, there's another potential type of problem that you're going to see in your homework assignments and on your tests and on your quizzes. Okay? And we haven't seen it yet. In any example that we've done, I haven't shown it to you, and I want to show you how to work through a slightly different example. Now, I know we could do this problem this way. I understand that. One other thing I also know is that this other non-right angle is 85 degrees because this angle and the 5 degree angle have to add up to 90. Now I'm going to use the 85 degree angle as my reference angle instead. I'm still going to use the tangent ratio, but I want to show you a little difference. If I were to take the tangent of 85, 250 would then be the opposite side, and the unknown side would then be adjacent. So my trig ratio would flip, and I'd have tangent of 280 equals 250 over a. Now take a look at this. Take a look at this. Pause if you need to. See if you can see the biggest difference between those two equations. That difference is that the unknown side a is on the bottom. Okay? Now we've seen several times here if the unknown quantity is on the top of the fraction, it just requires one step to solve to find it. If it's on the bottom, it requires two. And I want to show you how to do that. And again, I understand on this problem we don't have to do it this way, but sometimes we might. So I want to show you how to do that. The first step would be to multiply both sides by a. Okay, before this was actually a number, now it's a variable. That gives me a times the tangent of 85 degrees equals 250. And notice that just multiplying both sides by a does not lead to a solution because a is not by itself. If the variable is on the bottom of the fraction, it requires a second step of solving. And that would be to divide by the tangent of 85 degrees. Now a is by itself. Our decimal approximation can be made from taking 250 divided by the tangent of 85. And now from here we could solve it one of two ways. I would encourage you to verify it with both. To get a, we could take 250 times the tangent of 5 degrees, or we can take 250 and divide by the tangent of 85. We will get the same thing either way. The height of that building is approximately 21.9 meters. All right? So that is an example of how you would go about solving for an unknown side if that unknown quantity is down on the bottom of the fraction. Again, I know I didn't have to do that here. I just want to show you how. So you would be equipped to handle that case if you have to solve one that is structured like that. We'll call it quits there in 9-1 day 2. As always, if you have questions, please let me know. I don't expect that you're an expert on these topics from just watching this lesson. I do expect that if you have some questions left, that you are clear on what those questions are and you're prepared to ask those next time we see each other in class. All right, we'll see you then.